Morning, students. Students, this lesson is of class 8th for the subject of physics, and today we will do topic of speed and velocity, which is given in chapter 2, motion in one dimension, and is given on page number 30 of your physics textbook titled Concise Physics by Selena Publications. Children, this lesson is submitted to you on 19th April 2021. Children, starting with the word speed. Speed you have already learned in your physics as well as in your mathematics. Even in your daily life, you have used this word occasionally. Children, speed of a body is the rate of change of distance with time. You must be knowing the formula of speed, that is distance upon time. Now children, whenever there is division of time, we always write that quantity as rate. The word rate in physics means divided by time. So what is speed? Speed is rate of change of distance. So that means distance divided by time is speed. And children, speed is a scalar quantity. By the word scalar, I mean it does not depend on direction. Children, in the last video, we have learned that distance is also scalar. Moreover, time is also scalar. So, distance upon time is speed, which is also a scalar quantity. Just to remember, you can say S for speed and S for scalar. So, children, let us learn the unit of speed. If distance is measured in meter, then time is measured in seconds. So, standard international unit is meter per second. The standard international unit for speed is meter per second. And if we talk about CGS unit, children, here CGS, C stands for centimeter, G for gram, S for seconds. So CGS unit of speed is centimeter per second. Now before moving further, learn the definition of speed. What is speed? Rate of change of distance with time. Formula: speed is equal to distance upon time. Unit: SI unit is meter per second. CGS unit is centimeter per second. Children, moreover, meter per second can also be written as MS minus 1. Don't write M per S minus 1. No, wrong. There are two ways to write a unit. Either you say it as meter divided by second, that is meter per second, or M S inverse. Inverse means that S was in denominator. Then there is no sign to put, there is no need to put sign of per in between. Similarly, centimeter per second can be written as, write yourself. How to write down? Centimeter. If you don't want to put the sign of per, you can write down S minus 1. Centimeter second inverse. Similarly, students, if distance is measured in kilometer, then time we measure it in hour. So the unit becomes kilometer per hour, which can also be written as kilometer hour inverse. Now students, you must be knowing that in 1 kilometer we are having 1,000 meter. What does it mean? 1,000 meters are able to make 1 kilometer. We'll be taking thousands of meter and then we will be combining it, and that 1,000 meter will make 1 kilometer. Similarly, in an hour, we are having 60 minutes and 60 seconds. So we can say that in an hour, we are having 60 into 60 seconds. 60 multiplied by 60 seconds comes out to be 3,600 seconds. And 1 kilometer per hour can be written as, in 1 kilometer per hour means, listen, let us learn how to do it, children. Now, just if you are having 1 kilometer per hour, it means 1 kilometer divided by 1 hour. Write down 1 as it is. Kilometer means 1,000 meter. Similarly, in denominator, write down 1 as it is, and hour means 3,600 seconds. So 1 kilometer per hour is 1,000 upon 3,600 meter per second. If you cancel these zeros with each other, and then 2 5s are 10 and 2 18s are 36. So you can have a relation that 1 kilometer per hour, 1 kilometer per hour is 5 by 18 meter per second. So this is 1 kilometer per hour, which can be written as 5 by 18 meters per second. Children, coming further, I have given you 3 conversions. Kindly convert 10 meters per second into kilometer per hour, 72 kilometer per hour into meters per second, and 36 kilometer per hour into meter per minute. So I will be doing the third part with you. The rest 2 part you try yourself. We are having third part as 36 kilometer, 36 kilometer per hour needs to be converted into meter per minute. So how to do this question? You write down 36 kilometer. Per means divided by hour. So let's keep 36 as it is. 1 kilometer you are having 1,000 meter divided by hour. We have to convert hour into minutes and not seconds here. So in 1 hour, 60 minutes. So let's cancel 1 0 with it, and 6 6 are 36. So our answer is 600 meter per minute. 36 kilometer per hour can be written as 600 meter per minute. Again, I'll repeat what I have done. I have just changed kilometer into 1,000 meters. This is one way to write down. We can say 1 kilometer is 1,000 meter. And in an hour, we are having 60 minutes. So hour can be written as 60 minutes. Then we cancel it out, and the answer of 36 kilometer per hour will be 600 meter per minute. So students, you can pause this video and you can write down this conversion. So children, on page number 2 of the PDF sent to you, the conversions of meter per second into kilometer per hour and kilometer per hour into meters per second is shown to you. While the third part is also done and you can cross-check your answers with them. Now coming to the next topic, that is uniform speed. Children, the word uniform means constant. That is same. When you are coming to school, you all are wearing uniform. That means you all are wearing same kind of dress. So uniform means similarity, similar, same. So children, uniform speed. By its name, we can understand now that the speed is same throughout. That means you are traveling with same speed. So let us define uniform speed. A body is said to be moving with uniform speed if it covers equal distances in equal intervals of time throughout its motion. For example, if a body moves along a straight path and covers 8 kilometer distance in 1 hour, and then further in next 1 hour it is covering same 8 kilometer distance, and again in the next hour also if it is covering same distance. What does it mean? It means that the body is moving with constant speed. It is not increasing or decreasing its speed. Children, if the speed was increased, it would have covered more distance in an hour. And if its speed was decreased, if it was going slower, that means in an hour, it should have covered small distance because it is going slowly. Rather, this is not happening. Why? Because in this case, a body is moving along a straight path and it is covering equal distance in equal interval of time, and thus the body is moving with constant or uniform speed. So children, what is non-uniform speed? When the body is covering unequal distances in equal intervals of time. For example, a vehicle moving on a crowded road. If the road is crowded, you will move with different speed. Children, non-uniform speed is also known as variable speed. It is also known as variable, means which is changing constantly, variable speed. And non-uniform speed can be classified further into two categories: instantaneous and average speed. Now let us discuss one by one each kind of speeds. Children, instantaneous. The word instant means at the same moment, at the same point, same moment. So instantaneous speed. When the speed of a body keeps on changing Its speed at any instant, at any moment, is measured by finding the ratio of distance traveled in a very short interval of time. Children, you must have seen speedometer in front of the vehicle. Even in a two-wheeler or a four-wheeler, you are having a device which tells you the speed of the vehicle at that moment. Suppose at that dial, you are getting the speed of 60 km per hour. What does it mean? It means that at that time, at that particular time, the body is moving with 60 km per hour. It does not mean that the body earlier was moving with 60 km per hour speed. It does not mean the body will be moving with this speed. The speed shown on speedometer is the current speed. Current speed means the speed at the particular moment. So it is known as speed at that instant. At that instant. It means instantaneous speed. So speedometer of a vehicle measures the instantaneous speed. And now let us study what is average speed. Children, average speed can be found by calculating total distance traveled in total interval of time and then take the ratio of the two quantities. So the ratio of total distance traveled by the body to the total time of journey is called the average speed of the body. Children, for example, suppose you reach Delhi in 5 hours from Chandigarh and suppose the distance traveled is 245 kilometer. So the total distance between Chandigarh and Delhi is 245 kilometer and you took 5 hours to reach your destination. So what is your average speed? The average speed will be total distance 245 divided by total time, that is 5 hours. So 245 by 5 comes out to be 49 kilometer per hour. So that is the average speed. And children, average speed will be equal to instantaneous speed only if the body is moving with uniform speed. What I want to say? I want to say you that if average speed is 49 km per hour and instantaneous was also 49 km per hour, instantaneous is at the current moment. Suppose you watched your speed at 9 a.m. Then you watched the speed at speedometer at 9:10, then at 9:30, and the speedometer is showing always for the entire 5 hours, your speedometer is showing 49 km per hour. What does it mean? It means that your instantaneous speed at every time was equal to your average speed. And it means that the body was moving with uniform constant speed. So now coming to the next topic, that is velocity. Children, velocity of a body is the distance traveled per second by the body in a specified direction. Speed was also distance upon time. Velocity of a body is also distance traveled per second by the body, but in a specified direction, in a particular direction. Children, since we are having the word direction written here, what does it mean? It means that velocity is a vector quantity. It depends on direction. So children, just to remember, V for velocity, V for vector, S for speed, S for scalar. So children, in other words, we can define velocity as rate of change of displacement of a body with time. So rate of change of displacement of a body with time. So mathematically we can say that velocity is equal to not distance, rather displacement divided by time. In case of speed, instead of displacement, we were having distance. But here, velocity is displacement upon time. So children, you can see figure number 1. Now what happens in figure number 1? If a body moves at the speed of 20 kilometer per hour towards north direction, and then it turns towards east direction with same speed, 20 kilometer per hour. Now check, is there any change in the speed? Earlier speed was 20 and then also 20. So this is an example of uniform speed. Speed is not changing. But children, in case of velocity, we have to see speed as well as direction. Here speed is uniform. But is direction same or is it changing? There is change in direction. So children, if the speed is uniform but direction is changing, then also the velocity is not constant. So this is an example. Figure 1 can be said as an example of variable or non-uniform velocity. Why so? Because we have changed the path of the object. The direction is changed. Even if the velocity is variable, but the speed in this case was uniform. Speed was uniform, but since the direction has changed, thus the velocity is non-uniform. So children, here the SI unit and CGS unit of velocities is same as that of speed, that is meter per second and centimeter per second respectively. Now, when we can say the velocity to be uniform? Children, if a body travels equal distance, but all the distances are to be traveled in a particular direction, in a fixed direction, in equal intervals of time, then the body is called to be moving with a uniform velocity. Suppose a body is moving in a straight path and it covers equal distance in equal intervals. Or suppose every time if the body is moving in a straight path with a speed of 8 kilometer per hour. So is the speed changing? No, the speed is not changing. Is the direction changing? No, the direction is also not changing. So thus, the speed of the whole body is moving in a same direction. Thus, This is an example of uniform velocity. I hope uniform velocity is clear. You can read it yourself. Take a break. Read uniform velocity. I hope you have read by now. Now let us learn about non-uniform velocity, which can also be termed as variable velocity. Children, if a body moves unequal distances in a particular direction in equal intervals of time, for example, 20 kilometer in 1 hour, 25 kilometer in next 1 hour, 30 kilometer in the next hour, 15 kilometer in next hour. So is the speed constant? No, the speed will be also changing. Since speed is changing, velocity will also change. So this first example is also an example of variable speed. Here speed is also varying as well as velocity is also changing. But children, if a body moves equal distance in equal interval of time, if they are moving equal distance in equal interval of time, but in different directions, the directions are different, then the velocity of the body is said to be variable or non-uniform velocity. This has already been discussed in figure number 1. Moreover, you can see in figure 2 where there are two cases shown. In case 1, object A and B are moving in same direction with a speed of 20 kilometer per hour. So children, here in A, the object are moving in same direction with same speed. So A and B are showing uniform velocity as well as uniform speed. Speed is also same and their velocities are also same. But in second case, an object is moving straight and then turned towards right. But they are traveling with same speed, that is 20 kilometer per hour. In case 2, the body is moving with uniform speed, but the direction is changed. What does it mean? Yes, it means that speed here is uniform. C is moving with uniform speed, but with non-uniform velocity. Moreover, case 3, children, if an object moves in one direction, but with unequal speed, that is as we discussed the case 1 here, it is moving in one direction, but the speed is changing. Then again, the velocity will be variable. So in simple words, we can say that for an object to be moving with uniform velocity, both magnitude of distance, magnitude means value of distance traveled, and direction of motion should be same. Both things should be same. The distance traveled in particular time and the direction of motion in that particular time should be same. Only then the velocity will be uniform. Now, as we discussed instantaneous and average speed, similarly, we are having instantaneous velocity, which can be said as for a body moving with variable velocity, the velocity of the body at any particular instant is called its instantaneous velocity, while average velocity will be total displacement upon total time. So children, with this, I come to an end to this interactive session. You all are required to go through the PDF again and learn all the definitions and then try numerical number 1, 2, 3, 4, 5, 6 and 7. So kindly try these numericals in your physics notebook, which are given on page number 36 of your physics textbook. Thank you, students.